Okay, here's question number 4 in our free response question. This is from the 2018 AP Physics 1 exam. It was actually a 12-point question that I modified down to a 7-point question. And it's really a question that's about sort of data analysis and how to take a set of data like this and maybe try to linearize it in a way so that you might be able to um, uh, you know explore something. In this case, the students had prepared conductive dough, so like a Play-Doh that can conduct electricity, and they had molded it into cylinders with cross-sectional areas A and lengths L, and they applied a voltage across it, and from that determined what the resistance of that dough cylinder was. And the question really is, we'll explore this in a moment. The question is, how can we find rho, this resistivity, the sort of um, inherent kind of conductivity of this material based on the geometry and the electrical properties of it. But we have the equation, resistance, which is given, right, is equal to rho times L over A, and we have L and we have A, and all the data is in there. So let's take a look at the very first question. The first question it says which quantities would you want to graph in order to solve for the resistivity of the dough in order to solve for rho? And I decided that I would go back and look at the equation here. And I have R, which is kind of like where we might find Y, and then rho is my X, and L over A would be my slope. So if it was linear, I would expect to see um, R equals L over A times rho. And so I was going to graph resistance versus the computed column of L over A, which I put in right here. I computed these values based on L and A, and so on. Okay, I made a couple of errors there, as you see, but I eventually got some numbers. I want to highlight this here. Uh, you could also multiply both sides by A and maybe graph on the y-axis resistance times area and on the x-axis L. And again, the slope of that relationship should be rho. So that would be my strategy. Either the one I pursued or this one here would be equivalent. But in either case, you'd have to compute a column. I computed L over A. If you followed this bolded item right here, you'd have to compute R times A, and then you would graph R times A as your y-axis, L as your x-axis, and get your data from there. Okay, so the next question is, once you choose your axes, plot the points and determine the resistivity. So I went ahead and plotted my points. I made a rough scale down here of L over A, resistance from 20 up to 120. Plotted my points in there and drew in some kind of a best fit line. You can see it was very casual. I didn't even use a straight edge there, but I took my data points and plotted them. And then the third piece here is to compute the slope to estimate a value for the resistivity. So I took 2 points on the line. I guess I took this point right here, and then this point right here. So I had a difference in y of 100 and a difference in x of something like 320 minus 60, and so I had, oops, let me just move this a little bit. I got a slope of 100 over 260, which is 0.385. If you got an answer anywhere in the neighborhood of 0.4 or thereabouts, I gave you credit for that. So you don't have to know anything about the properties here. Everything's kind of given to you. You just need to kind of look at the equation, look at the definition, which is given on the resource page, and think carefully about the mathematical relationship between r and rho, with L over A as being a slope. Okay, so relatively straightforward, if a little bit unusual or unfamiliar, but it's a good example of just reading through the problem carefully and understanding exactly what you're being asked for.